It has these x-intercepts. It has a third degree, like x cubed, and it passes through the point 2, 36. So here's the way you're going to set that up. We do not know the stretch factor. So we're going to call that A. We don't know if it's concave up, concave down. Then we're going to use the 3 zeros to write our 3 different factors out. So if it has a 0, an x-intercept at -2, I know that x plus 2 is one of my factors, right? Because then when I plug in -2, I get one of my x-intercepts. What are my other 2 factors then? If 3 is my next x-intercept, what does my x minus 3 would go here, right? My factor would be x minus 3 if 3 is my x-intercept. So what's my last factor here? To get positive 5, my factor would have to be x minus 5. Does that kind of make sense where I got those factors from? To me, you should be able to get the factors from the zeros. This little bit challenge part says, okay, this function goes through the point 2, 36. You need to use that to figure out what that stretch factor is. So we're going to plug in the 2 for all of the x values, and we're going to plug in 36 as the y value and see if we can do the algebra to figure out what a would have to be. So you're going to plug in 2's. What would I get? 36 equals a still. In this first parenthesis, 2 plus 2 would give me 4. In the next parenthesis, 2 minus 3 would give me -1. And in the last parenthesis, 2 minus 5 is -3. What does that multiply to on the right-hand side? 4 times -1 times -3 is how much? Does everyone see how that's positive 12? So can't I divide both sides of the equation by positive 12 to get a by itself? So that tells me my a value is 3. That's a lot of steps to remember. So to me, you can kind of write that this would be like a bonus next to there. But I know some of you like getting bonuses correct, so I wanted to show you how to do it. So y equals 3 times x plus 2, x minus 3, x minus 5. So this polynomial satisfies all that information. It has these 3 x-intercepts. It is a degree of 3, because x times x times x is x cubed. And I plugged in 2, 36, and I know that the 3 there will make it a true statement. So give the one on the homework a try. It's very similar to that type of problem, how to set it up. And then maybe it'll give you confidence if that's a bonus. All right, so then I wanted to jump in and look at a couple examples from last time together, and then maybe after lunch, have you try a couple of these on your own. So this is like all the vocabulary I threw at you yesterday. And I'm giving you some factored form polynomials, and then you've got to like kind of unpack all this information. So it is a lot, but that's why there's a lot of practice problems. I don't think we're going to do, oh, you know what? These aren't in factored form though. Okay, so anyway, I'll go through this first one with you, and then maybe you can kind of work through this one as well. What is the total degree of this function? So this is in factored form, right? I need to think about what is the total power of this whole function. So this is x cubed times x, and this is actually times x squared over here. What would be my total power of x's? Let's see, we've got 3 plus 1 plus 2. So my total power would be x to the 6th. That's the hardest part of this problem, is thinking about what the power of x's would be when you multiply this out. Let's just do this one. Let's kind of hit these skills side by side. What would be the degree of this function? This is x squared, and this is x to the 1st. So altogether, our degree would be 3. All right, let's look at this one. What's our leading coefficient? So if you were going to multiply everything out, oh, hey. Oh, sure. Yeah. So all I care about is the leading coefficient. Is it going to be positive or negative? So see how there's a -5 right here? Technically, that -5 is going to get multiplied by a 9 from over here because 3 squared is 9. So technically, it's -45. All I care about is that my leading coefficient is negative. What about the your turn problem? What would be the leading coefficient over here, positive or negative? Positive. See how when you multiply those out, you'd get +1 in front? All right, this information is how you get your right and left end behavior. Do you remember which one goes with the right end? What tells me about my right end behavior? That would be the leading coefficient, right? So the leading coefficient is negative. What does that tell me about the right side of my graph? It's going down. So over here, I've got a positive leading coefficient, so the right end over here would have to go up. So this is what tells you this piece of information. Now the degree tells me if it's even, they're going to go in the same direction, and if it's odd, opposite directions. So is 6 an even or an odd number? 6 is even. So these two are linked. They're both going to go down. So even, they go the same direction. But over here, my degree is 3, which is an odd degree. So I'm going to do one of these, one up, one down, right? So this one happens to be up, so the other one is going to go down. And that is a really confusing rule. So you always think back to your friend, the parabola, because the parabola, I don't think you guys are confused about anymore, right? If I have 3x squared, I know that this tells me, right, I'm concave up, and this is what's telling me they're going in the same direction. So think about your friend, the parabola, is that up or down? And okay, so now this is the last part of what we learned yesterday. How do I think about the zero? Did you guys have a question? Oh, you got the zeros of the function, their multiplicity, and if they're going to bounce off or cut through the axis, and we're going to sketch a graph. So let's read this function across. What would be my first x-intercept right here from the -5x cubed? X would have to be, anytime there's an x by itself out front, it's 0, right? Because 5 times 0 is 0. So I'm going to write down 0 is my first 0, x-intercept. What is its multiplicity? So what power is hanging out here? 3, which is an odd number. Will it bounce off or will it cut through the x-axis? So if it's odd, it cuts through. So when I draw that x-intercept, it's going to go through the x-axis. So now I go to the next factor. What is my next 0? If this is x plus 5, my 0 is at -5. What is its multiplicity? I have a power of 1. So it has a 1 multiplicity, which also means 1 is an odd number. So it's going to cut through the x-axis. What's my last x-intercept? This is one of the kind of tricky ones I talked about a few minutes ago. What will make 3x plus 1 equal 0? So -1, because it goes to the other side, and then divided by 3 would make it -1 divided by 3, -1/3. So -1/3 is my other 0. What is its multiplicity? So it has a power of 2 this time, which is even. So this is the only x-intercept that will bounce off the x-axis. And I like to read, so you basically just read the function from the left all the way to the right. So you found the 0 and its multiplicity, the 0 and its multiplicity, the 0 and its multiplicity. So you read the function all the way across. So let's sketch what this graph will look like. I'm going to plot my x-intercepts. So I have 0, -5 would be way over here, and -1/3 would be here. And I've already written down the end behavior. So I know that it goes down on the right and down on the left because I already discussed end behavior. Where do I need to bounce? I need to bounce off at -1/3. So I actually need to cut through. So I'm going to go up a little ways, come back down. I need to bounce off here. It's like an M, a letter M, something like that. I'm not sure how tall these go, but it kind of waves through. So let's see how close we got. We got -5x cubed times x plus 5 to the first times 3x plus 1 squared. So let's see if we got the general idea here. So there, okay, so it bounced off really, really close, and it was so close to the axis you could barely see this little tiny jump up. But it went up, it bounced off, and then it went through there. So mine is kind of an exaggerated M. All right, see if you can, we're here till what, 49. You should have enough time to look at these zeros and their multiplicity, and if they would bounce off or cut through, and sketch a graph. And I'll put the answer up in about like 3. Are you still trying it? Oh, it sounded like you were just talking. Okay. You should be able to bounce off one. Did you try your end behavior as well? Okay, let's just see. My 0 would be at 5, right? 5, its multiplicity is 2, which is even, so I'm going to bounce at 5. Negative 8 has a multiplicity of 1, which is odd, so I'm going to cut through at 8, right? Is that what you got for that? So now I got to plot them. So let's see. I'm at negative 8 over here, and I'm at positive 5. My right end is going to go up, and my left end is going to go down. And let's see, I said I had to bounce off at 5. So this one would bounce, and then this one would cut through. So bounce off, cut through, and that connects my endpoints. So you need the whole picture, the zeros, the multiplicity, and the end behavior. And so to me, this is a type of question you'll see on your test on the non-calculator part. Answer these types of questions from a factored polynomial and sketch the graph. So like that exact question is one of the free response questions like without a calculator. So we need to do more practice on how to find the degree, how to find right and left end behavior, how to find the zeros and the multiplicity. So there'll be one like that on your review sheet and on your team test to keep practicing that. So